Number 1. In the classic novel Don Quixote, the title character famously battles a windmill. In this problem, we will model what happens when Don Quixote battles a windmill and the windmill wins. Poor Don Quixote. Suppose the center of the windmill is 20 feet off the ground. Here's the windmill. It's 20 feet off the ground. And the sails are 15 feet long. Don Quixote is caught on the tip of one of the sails, so I'm going to assume this little person up here is Don Quixote. And apparently, he doesn't have a mouth. He only has 2 eyes, and that's it on his face. The sails are turning at a rate of 1 counterclockwise rotation every 60 seconds. So Don Quixote's height, Don Quixote appears to be spinning around this circle here. And it takes 60 seconds to go once around this circle. So explain why a sinusoidal function can be used to model Don Quixote's height. Well, the dead giveaway that we're going to use the sinusoidal function is the fact that it's periodic. It has a period, this function. The period is 1 counterclockwise rotation every 60 seconds. So it takes 60 seconds to go 1 full rotation around the circle. And also the fact that we're spinning around a circle. So your explanation, which should be a complete sentence, should talk about the function having a period of 60 seconds and the fact that we're modeling the height of a circle. And we know when we're modeling the height of a circle, clearly a sine function or a cosine function should be used. The next part says, sketch a graph of Don Quixote's height above the ground as a function of time. Let t equal 0 correspond to a time when he was closest to the ground. Well, Don Quixote was closest to the ground here. This is a radius of the circle, and the radius is 15 feet. So Don Quixote was 5 feet off the ground. So on my graph, I need to make Don Quixote 5 feet off the ground at time equals 0. There's Don Quixote's initial height. Don Quixote then increases, and he keeps increasing all the way until he gets back up to, well, how high is that? This is 15, that's another 15, but I have that initial 5, so the highest Don Quixote could possibly be is 35 feet off the ground. Slide down. So the highest Don Quixote could be is 35 feet. He reaches that halfway through his spin, and then 1 full rotation, which is 60 seconds, he's back at 5 feet, because he kept spinning back around the circle. He's spinning this way. Don Quixote is spinning around that way. So, is this a sine curve or a cosine curve? Well, I see that hill there. That hill is letting me know that it's a cosine curve. The hill's letting me know I have a cosine curve here. The midline is in the middle. What is the midline of this function? Well, I need to be halfway between 35 and 5. So what puts me halfway? Well, what was the center point? The center was 20 feet off the ground. That center represents the midline. That's halfway between 35 and 5. How far up and down do I go from the midline? That's going to be my amplitude. Is 15. 20 to 35 is 15, and 20 down to 5 is also 15. So my amplitude is 15. Midline is y equals 20. And we know the period is 60 seconds. So, using all this information, we can now write the equation. If the period is 60 seconds, I don't really need to use the period to write the equation. I need the frequency. And we know that b times p equals 2 pi. Divide by 60 and get b equals pi over 30. Now we can write the equation. We can write the equation. Let's use h of t for Don Quixote's height off the ground. Don Quixote's height is amplitude of 15. We said this was a cosine curve, but wait a minute. This is starting at its minimum, not its maximum, so it's a negative 15 cosine. We said b was pi over 30 t, because I have to use t, because they said t equals 0 corresponds to that point. And I need to shift up 20. I need to shift the midline up 20. This is the equation of a sinusoidal function that models Don Quixote's height on this windmill. I don't know how you battle a windmill, but Don Quixote is. So, the next thing we want to do is model Don Quixote's height h above the ground as a function of t. Oops, I just did that. We just modeled Don Quixote's height, and we used h of t. Our model was h of t. H of t equals negative 15 cosine of pi over 30 t plus 20. After 1 minute and 40 seconds, Don Quixote fell straight down off the windmill. How far did he fall? So Don Quixote spun around for 1 minute and 40 seconds and then fell. Well, my input, my t values are in seconds, because we said the period was 60 seconds. So 1 minute and 40 seconds, so that's 60 plus 40. 60 plus 40 is 100. So I'm inputting, this is, I want to know what's his height at 100 seconds. So let's find h of 100. H of 100 is negative 15 cosine of pi over 30 times 100 plus 20. We get negative 15 cosine of 100 divided by 30 is 10 pi over 3 plus 20. We haven't done this in a while, but 10 pi over 3 is in radians, and my brain works with radians. Yours might not yet. So to get rid of the radians, I know 180 degrees is pi radians. So using this idea here, 3 divided by 180 is 60. That's really 600 degrees. Spinning around 1 minute and 40 seconds rotated me 600 degrees. So this is negative 15 cosine of 600 degrees plus 20. Well, what's the cosine of 600 degrees? I have no idea because 600 is too big. So let's subtract 360 from that. Let's subtract 360 degrees from 360 to get 240. And we need to get the cosine of 240 degrees plus 20. Now, honestly, at this point, you could have plugged this in your calculator as long as your calculator's in radian mode, and you'd be good to go. But 240 is a special angle, because 240 degrees, if you remember, is in the third quadrant. That's 180, which means my reference angle is 60. And in quadrant 3, it's negative. So the cosine of 60 degrees is a half. So in quadrant 3, that's negative 1/2. So we really have negative 15 times negative 1/2 plus 20. This will tell me his height. Well, that gives me 7.5 plus 20. So h of 100 is 27.5. Don Quixote fell 27.5 feet. So I guess the windmill beats you when you fall 27 feet off of it. Again, at this point, you could have went to your TI-80, 483, whatever device you have, and typed that in as long as you were in radian mode. Negative 15 cosine, 10 pi over 3 plus 20. And that would have given you 27.5, hopefully, unless I did something wrong. But we know I never do that. That was the Don Quixote problem. We modeled his height on this circle by using amplitude, midline, and frequency and period, that relationship to find the p-value. Number 2, a Ferris wheel is constructed such that a person gets on the wheel at its lowest point, so we get on at the minimum, 5 feet above the ground. So the lowest my Ferris wheel goes is 5, and reaches its highest point at 130 feet above the ground. This is a big Ferris wheel. The amount of time it takes to complete one full rotation is 8 minutes. One full cycle, one full rotation is screaming that the period equals 8 minutes. Sketch a graph of the person's vertical position for one full rotation. So it said we get on at the lowest point. It increases up to 300, and then it's going to decrease down back to 130, and decrease back down to 5 after 8 minutes. So if you wanted to label the maximum happens at 4. We want to know the midline. We want to know the midline of this function. What is the middle here? What is the middle between 130 and 5? Well, these are 125 apart. And if I divide that by 2, that'll tell me how far I need to go up and down. 125 divided by 2 gives me 62.5. So I need to go up 62.5 and down 62.5. So if I go up from 5, that gives me 67.5. 67.5, y equals 67.5 is my midline. Determine a sinusoidal equation that models a person's vertical distance after t minutes since the ride has started. So now we just need to write the equation of this trigonometric graph here. And we have all the information that we need. We know the midline is y equals 67.5. The amplitude is half this distance. How far did I go up? I went up 62.5 and went down 62.5. It has this negative cosine shape, so we know it's y equals negative 62.5 cosine, because I'm starting low and I have a cosine curve here, of something that I need to find, plus 67.5. How do I find my b value? I know the period equals 8, so b times 8 equals 2 pi. b equals, divide both sides by 8, 2 pi over 8, which is better known as pi over 4. So the b value is pi over 4. I'm not going to put x, I'm going to put t, because that's the variable they used. This equation here models this sinusoidal relationship. It models the person's height. If you get on at the bottom of the Ferris wheel, you spin around the Ferris wheel and your height goes up, and then you goes back down for one full cycle. It's important that you can sketch the graph and pick out the key information from this verbal description of the relationship. The graph, I think, truly helps you write this equation because it lets you see, oh, it's a cosine curve, or oh, it's a sine curve. Here's my midline, it's in the middle. We'll practice more modeling tomorrow. We'll practice modeling more relationships with sine and cosine.